Hello class. For today, 10.3, we'll be learning about percentage increases and decreases. Now, our learning objectives are two. We're going to calculate the percentage increase or decrease from a set of given values. So if we're given certain numbers and the numbers represent a change, how do we calculate the percentage change, whether it's an increase or a decrease? The second learning objective is to learn how to calculate the amount of an increase or a decrease from a given percentage. If we're given a certain number and then given a percentage increase or decrease, how do we calculate the new value? Okay, we're going to start off with a couple of simple formulas. Now, the first one is pretty obvious. We know that an increase is when we have the new value subtracted by the original value, and the new value is greater than the original value. Okay, a percentage increase is when we have the increase from the new value minus the original value, we divide that by the original value, and then we multiply that by 100 in order to get a percentage. Let's do a simple practice question first, involving the formula that we just learned. Okay, we have here, Daniel gets $500 a week as part of his allowance. He spends 20% of it on food. The next week he spends 35% of his allowance on food. Find the percentage increase in his spending on food. So first off, remember, look back here, we got to calculate the increase, and then we calculate the percentage increase. So our increase in this case would be the new value, which is 35% of 500. So we can write 0.35 times 500, okay, minus the old value, which is 20%. Okay, 0.20 or just 0.2 times 500. Okay, and we'll find that we get 175 as his new value and 100 as his previous expenditure for food. So of course, the increase is in $75. Now, how much of an increase is that? Okay, remember, let's look at that one more time at our formula. The percentage increase is the increase divided by the original value times 100. So our increase is 75. We divide that by the original value, which is 100. He was originally spending $100 a week. We multiply that by 100%, and we find that our answer is 75%. Okay, so his expenditure, his spending on food has increased by 75%. Okay, do not just subtract the percentages. His percentage did not increase by 15%. It's not 35 minus 20, but rather you're supposed to calculate it this way. Find the increase, the number that's the increase, and then find a percentage. For practice, I'd like everyone to try page 36, number 9, the tried question, and your answer should be 20%. For our next example question, we're going to try using a new formula. Okay, and the formula is like so. The new value is equal to the original value times 100% plus the percentage increase. This means that if we have any two of these, either the new value, the original value, the percentage increase, any two of them, we'll be able to calculate the other one that we don't know. Okay, so let's look at our example here. S1M answered 48 math questions this week. This is a 20% increase from the number of questions they answered last week. How many math questions did they answer last week? Okay, so which two of these three do we know? We have 48 math questions this week, which would be our new value, okay, and a 20% increase, which is our percentage increase. That means we need to find this, the original value. Okay, so, all right, so we write down 48, which is the new value. Okay, we can let x represent the original value. Okay, so 48 equals x times 100 plus 20%. Okay. So 48 equals 120% times x. So we can just represent it as 1.2. Okay, so we simplify this by dividing both sides by 1.2. x equals 48 divided by 1.2, and that should give us 40. Okay, 40 is the original value, which is the number of math questions they answered last week. So for your practice, okay, I'd like everyone to try page 37. Sorry, page 37, number 11, and the answer is 125 centimeters. Okay, next up, we're going to look at the similar formulas that we just learned, except for percentage decreases. Okay, now the first formula is pretty simple and basic. A decrease is the original value minus the new value. Okay, in this case, the new value should be less than the original value. Okay. The percentage decrease is the decrease, which we find here, divided by the original value times 100%. Or we can also use this formula. The new value equals the original value times 100 minus the percentage decrease. Okay, so what do you notice different about these two formulas compared to calculating the percentage increase? Okay. For this formula, we see that increase is just replaced with decrease here. The formula is basically the same. Okay, you divide it by the original value and you multiply it by 100%. For this formula, our key difference is right here. Okay, instead of adding the percentage increase, we subtract the percentage decrease. Okay, so keep that in mind and make sure not to make that mistake. Let's look at the example question. The temperature in Hong Kong fell from 24 degrees to 18 degrees. Find the percentage change in temperature. So for this question, we can use these two formulas since we're given the new value and the original value and the new value. Okay. So our decrease is 24 minus 18, which is 6. Okay, and our percentage decrease, we'll apply this formula right here, is 6 over 24 times 100%. And we'll find that that is equal to 25%. Okay, so the temperature fell by 25% when it went from 24 degrees to 18 degrees Celsius. Okay, for practice now, I'd like everyone to try page 38. Try question number 12. Okay, and the answer should be 15%. Okay, example number 4. The speed of the wind blowing through Hong Kong is expected to slow down by 5% to 24 kilometers an hour in a week. What is the current speed of the wind? Okay, this time, which formula should we be using? Okay, it should be the third one. Okay, because we are given the new value and a percentage decrease. So with that, we can find the original value. Okay, so we simply plug in the numbers into our formula. Okay, remember, we have our new value, which is 24. That is equal to, you can say x for the old value. Okay, don't forget to write your let statement. Let x represent the current wind speed. Okay, and in brackets, we put 100% minus, don't forget minus, not plus, the percentage decrease, which would be 5%. Okay, so 24 equals, we can write the percentage as decimal form by dividing by 100, so 0.95x. Okay, we divide both sides by 0.95. X equals 24 divided by 0.95. And in this case, x should be 25.3 kilometers an hour. Okay, so the original current speed of the wind is 25.3 kilometers per hour, rounded to one decimal place. Okay, and if it slows down by 5%, that means it's 24 kilometers an hour. All right, for practice, I'd like everyone to try the try question on page 38, number 14, and your answer should be 66.7 kilograms when rounded to one decimal place. Okay, our last question is probably the most complicated one. Nelson's grandmother's height is 130% of Nelson's height. His grandmother's height falls by 10% in the next 2 years. by what percentage must Nelson increase his height so that he will be equally tall as his grandmother in 2 years? Okay, so we can let, just as usual, we probably need a variable. We need to have a variable x. Okay, so let x represent, okay, Nelson's height. Okay, so the grandmother's height, we'll just write GM. Okay, GM's height in this case, okay, would fall by 90%. Okay, that means it'll fall by 10%, so it'll be 90% of his current height. So her current height. So 90%, you can write that as a fraction, okay, times her current height, which would be 130 over 100x. Okay, and if it makes it easier, you can write it in decimal form. Okay, so 0.9 times 1.3x. Okay, that should give you 1.17x. Okay, so the required growth, okay, in this case would be 1.17x, okay, which is the height that he needs to achieve. Okay, the new height minus x, the old height. Okay, remember this is how you calculate the increase. Okay, we divide that by the current height, which is x, and we multiply that by 100%. So our answer should be 17%. Okay, so that's one way of answering the question. That's one method. Our second method, okay, is to have two variables instead. Okay, we can have let y represent the percentage growth required. Okay, so in this case we can have x, which is Nelson's height. Okay, we need to have 100 plus 100% rather plus y%. Okay, so with that required growth, it will be equal to 90%, okay, of 130% of x. Okay, so x plus 100% plus y% would equal 117% of x. Okay, so if we divide both sides by x, that will get rid of the x here. So we'll just have 100% plus y% equals 117%. Okay, we rearrange the numbers. Y% equals 117% minus 100%, and y% is 17%. Okay, or y rather is 17%. Okay, so you have two methods of answering the question here. Okay, I personally think the first one is a bit easier, but you're free to use both methods. Okay, our last practice question, okay, is on page 39, and it's number 15. And your answer should be 60%. Okay, so that's it for today's lesson. Remember, there are more examples in the textbook. Okay? The examples that I gave you are ones that I made up. You can look at the textbook examples. They're very similar to the ones that I just gave you. And that should give you a better understanding of what we learned today.